Hello, and welcome to 5 Minute Math. Today we are looking at the 7th grade concept of simple and compound probabilities. This is 7.6i Readiness Practice, the advanced version. If you are interested in exploring the 7.6i Readiness Practice for the intermediate or proficient versions, or the Readiness Practice resource along with any other standard, you can find those by using a link in the video description. So we have a spinner and we have a die, a six-sided fair die, which means it's not rigged in any way. With it, the numbers 1 through 6. So we need a theoretical probability, and then we also have an experimental question. So let's draw a picture of what we have here. So I'm going to give myself a circle, and that's going to be my spinner. So let's say that's my circle, and I've got my spinner, and what are my four options here? I've got yellow, green, blue, and red. So there's my green, my yellow, blue, and my red. I always like drawing a picture if possible. Helps me kind of visualize what's happening. And then I've got a spinner, right? And it's supposed to land on a green. So let's go ahead and just put our little spinner right there. And then we've got a six-sided die. Okay, so it's just a number cube, right? And it's fair. So we could do this, right? And you've got your dots going like this. And what it should land on is an even number. Okay, so let's look at our probabilities. What is the theoretical probability of spinning a green and rolling an even number? All right. Well, green, how many greens are there? Right, this is a compound probability because we've got two simple probabilities linked together, but we're gonna first find the simple probability of each. So I've got one green out of four possible choices. That's my theoretical probability of landing on the green spinner. Now, even numbers, right? I've got six possible choices. And how many of them are even? Well, 2, 4, and 6. So 3 out of 6. Or, honestly, if I want to, I can say half. Half are odd, half are even. Now, that's the probability of getting an even. So what is the theoretical probability of spinning a green and rolling an even number? Well, what we do to find the compound probabilities, we just multiply the probability of each individual event. So I'm going to look at 1/4 times 1/2, and we've got 1/8. So my theoretical probability of landing on a green and then getting an even number, put that blue so we see that link here, is 1/8. Now let's look at the experimental probability. We're going to do it 50 times and it happens 10 times. What is the experimental probability? Well, that's going to be slightly different. This first one up here is theoretical. That's what should happen. That's how I like to define theoretical. That's what should happen based on the probabilities. The experimental is what actually happened. Life doesn't always work out the way that it should. And so I've got 10 instances of it, and it was out of 50 tries. So, I mean, that's our fraction. Our experimental probability is 10 out of 50. Let's go ahead and simplify it to 1/5. So it actually worked out more than it should have. It should have worked out 1 out of 8 times, right? About 12.5%. It actually worked out 20% of the time at the 1/5. So that is my theoretical and my experimental probability. For number 2, we've got a game that involves two different spinners. We have a spinner 1, we have a spinner 2. And then look, spinner 1 has three equally likely sections labeled 1, 2, and 3. So if we want to, we can kind of visually represent that. So I'm going to make this spinner 1. And let's get it over to the lines. There we go. Spinner 1. And I'm just going to cut it into thirds. This and three equally likely sections labeled 1, 2, and 3. There we go. Now spinner 2. Let's get another circle. All right. And it has two equally likely sections. and it's labeled A and B. So we'll just cut that in half. There's my A, there's my B. All right. And then it was spun 40 times, and here's my frequency. You see I've got my table here showing all my likely outcomes. Okay. What is the experimental probability of spinning a 2 on spinner 1 and then a B on spinner 2? So let's look. I'll make it blue here. So on this one, we're going to spin a 2 on spinner 1. So that's these two right here. And then a B on spinner 2, that's this one right here. So I'm looking at this outcome right here. Let's make that blue. And so how many is it? Well, it's 6 results, right, out of 40. So we still need to simplify. We could say 3 out of 20. So the experimental probability of landing on a 2 and then a B is 3/20. All right, let's look at our next one. We'll make it red. What is the theoretical probability? The first one was experimental. Now it's theoretical, so we don't need the data table. Of spinning a 2 on spinner 1 and a B on spinner 1, assuming both spinners are fair. So it's the same combo, but now it's theoretical. Well, how many 2s are there on spinner 1? Well, there's 1. How many total choices are there in spinner 1? There's 3. So the theoretical probability of landing on a 2 on spinner 1 is 1/3. We're going to multiply that by how many B's are there on spinner 2, 1. How many total choices are there? 2. So the theoretical probability of landing on a B is 1/2. We multiply those and we get 1/6. So 1/6 is our theoretical probability of landing on a B, which is obviously slightly different than the 3/20. And that's just because it's just different. Theoretical doesn't always match the experimental. And so how do the experimental and the theoretical probabilities compare in this case? Okay, so let's do a little comparison here. So we want to compare our 3/20. That's our experimental, and our theoretical 1/6, right? Well, we can compare it a few different ways. We can make them into decimals, right? We can uh, change into same fractions, right? So I know that 1/6 is, I'm going to do percents. There's more than one way to do it. It's 16.6 repeating percent. Okay, that's just what 1/6 is. Now, I'm going to compare if I get the other one into a percent. And so 3/20 is 15%. And so it's just a little bit below. And so we'll say that our experimental is just slightly less than our theoretical. And we have, so we can write a statement. We can say that the experimental that's what actually happened, right? When we did uh, our trials is slightly less than the theoretical probability. And so that's always good to kind of look at the theoretical, do some tests, and see if it really works. You could do the same thing with flipping a coin, right? See how many times it should land on head, how many times it should land on tails. Should be 1/2, but if you do it 10 times, you might not get an even 5 and 5 in the theoretical probability. Let's finish this out. All right, so the big key here is obviously keeping in mind the difference between experimental and theoretical. Finally, we have a spinner with 4 equal sections, and we're flipping a coin. Okay, so let's do both. Let's get a spinner, put it down here. Let's do that. 4 equal sections, that's pretty simple. Labeled A, B, C, D. And A, B, C, D. And then we also have a coin. So I'm just going to draw like a coin like this. It's the edge. And I'm just going to write 10 cents here, just to kind of keep in mind that it's a coin, which means it's going to have, heads and tails. List the sample spaces for all possible outcomes. Okay, so let's make our sample space first. And so we've got two different things we're dealing with. We've got a spinner. We're going to deal with that first. And then we've got the coin. Okay. And what we could do is we can kind of look at them as ordered pairs. And so I'll make a table and then we can make the sample space, right? So I'm going to say if I land on an A first, there are two choices. I could do A and heads, A and tails. I could do the same thing with B. B and heads, B and tails. And then the same thing with C, two C's, heads and tails. And I could do two D's, heads and tails. All right, so that's a table listing all of my possible, like we did on problem 2. If I wanted to make my sample space, right, I can list it as a list here. What I'm going to do is I'm just going to write it like this, AH. That's A with the heads, A with the tails, B with the heads, B with the tails, C with the heads, C with the tails, D with the heads, and then D with the tails. All right, so that's one way to list a sample space. The table, obviously, tree diagram will end up showing you the exact same thing, but it's slightly different than sample space. So that's my sample space. What is the theoretical probability of getting a vowel? Oh, a vowel with tails. Well, I'm going to use my table to help me figure out what that is. Obviously, you see I've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, I've got 8 possible choices. And so my theoretical probability is going to be, well, how many vowels are there? I've got A, B, C. I've got 1. Let's draw an arrow so we know where that is. 1/4, because A is my only vowel, times tails, 1/2. So that's going to get me 1/8. So the theoretical probability is 1 out of 8 tries should get me a vowel and a tails. In an experiment, the action is performed 40 times. Outcome A and tails occurred 6 times. What is the experimental probability? Well, they give us the numbers we need. A and tails occurred 6 out of 40 times. So let's simplify that, and that's going to be 3/20. And that would be our experimental probability, slightly different than, the 1/8. So if you're interested in exploring this 7.6i readiness practice for the proficient or intermediate versions, or the readiness practice resource along with any other standard, you could find those by using the link in the video description.